Hello, I welcome you all to this another interesting screencast. The problem reads when the driver applies the brakes over a light truck traveling 40 kilometers per hour, it skids 3 meters before stopping. How far will the truck skid if it is traveling 80 kilometers per hour when the brakes are applied? This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. We are going to use the principle of work and energy to solve this particular problem. You can solve it using other methods, but for this chapter 14, we are going to use this particular principle. And in this principle, we are saying the initial kinetic energy plus the total work done from point 1 to point 2 is equal to the final kinetic energy. For the work done, if we have the force in this direction and the displacement in this direction, then we call such a work as positive. And if the force is in this direction and the displacement in the opposite direction, then such work is going to be classified as negative work. Kinetic energy is always going to be positive, always, because the velocity is squared. Alright, so for the vehicle to, when the driver applies the brakes and the vehicle skids, okay, this skidding is sliding, right? It's the same as sliding. The skidding is sliding, okay? So it means there's going to be friction on the ground. Friction has to be there for the vehicle to skid. If there is no friction, then we don't expect the vehicle to stop, right? So friction will allow this vehicle to stop to a certain point, okay? Right. So let's say we have the wedge, okay, and then we have the total normal force. This is the total normal force, and since the vehicle has stopped, then it begins, the brakes are applied, it begins to skid, then we expect friction force to be in this direction. So let's call this friction force as friction force in motion. Okay, so call it Fk, K for kinetic. We have the normal force like so, and we have the weight. Right. So let's find this friction force is equal to mu K N. But yeah, mu K N. All right. So let's work out this particular problem. Let's find this Fk, okay, and we assume this Fk is going to be constant so that we use it. So we are finding the maximum Fk here, right? Right. Let's start working on the problem. Let's say this is case 1. All right, so in this case, let's say we have V1 equal to 40 kilometers per hour. Let's convert this to meters per hour. So multiply this by, using the unit analysis method, 1000. We want to change kilometer to meters, divided by 1 kilometer. We convert the hours to second. We know that 1 hour is equal to 3600 seconds. And you've seen the way we are arranging them in the manner that what we do not want gets cancelled out, okay? Therefore our v1 is going to be equal to just 40. All right, so this gives us 11.11 meters per second. Our v2 is just going to be equal to 0 meters per second. Okay, here S1 is going to be equal to 0, and then S2 is going to be equal to 3 meters. So with this information, we want to use the equation KE1, which is the initial kinetic energy plus the total work from 1 to 2 is equal to KE2. So KE1, this is just going to be equal to half mv1 squared, and this is equal to half mass times so the brakes are applied when the velocity is 11.11 meters. Alright, so what do we have here? Our KE1 therefore is just going to be equal to 11.11 squared. Alright, so this becomes 61.7105 m, right? And then KE2 as half mv2 squared, and this is just equal to m2 0 squared. This is just equal to 0. Alright, so at this stage let's find the total work, which is going to be equal to, so we have Fk in this direction, we have the displacement in this direction, therefore the work here is negative work. Right, so this gives us minus integral S1 is 0, S2 is 3, then we have Fk like so, ds, and this just gives us a minus 3 Fk. And now summing up everything, so summing up all the equations here, all the components in our equation, we have 61.71605 minus 3 Fk equal to 0. Making Fk subject to formula, we have this gives us a 20.57 m. Okay, so found Fk. Let's go to case 2. We go to case 2. Case 2, what do we have? We have V1, which is just equal to 80 kilometers per hour. Converting this to meters per second, we do the same like we did in the other case. Okay, so therefore our V1 is just equal to so this becomes a 22.22. Alright, so our S1 here will be equal to 0. So our V2, since this vehicle come to a stop, so it will be 0, and our S2 is just equal to S. That's what we are looking for. So using dot equation, let's find what K1 is. Our K1 is just half m 22.2 squared. This gives us a 246.8642 m. KE2 this is equal to 0. And then summation of total work, this is just equal to integral from 0 to s of 20.57 m ds. And this we get, and this is negative also, this we get a minus 20.57 m s. Summing up all these, we have a 246.8642 m minus 2.557 ms equal to 0. So m and m goes, therefore our s is just going to be equal to a 12.00. Therefore S2 is just equal to 12.00 meters. 246.8642. Alright, I think this is about it. We have found the magnitude of the slipping distance when the track is traveling at 80 kilometers per hour. I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.